Hello students, now we are going to solve the rest of the statements of question number 1 of exercise 3.5. So F part says that all numbers which are divisible by 4 must also be divisible by 8. So let's solve this statement by taking an example. If I take a number 20, okay, we know that 20 is divisible by 4. Now let's check, is 20 is divisible by 8? 8 2s are 16 and 20 minus 16, that is 4. We get here remainder, not 0. So that means 20 is not divisible by 8. Statement says that if a number is divisible by 4, it must be divisible by 8. But here we get contradiction. That means we take a number and we divide that number with 4. It is divisible by 4, but it's not divisible by 8. So that means it's not necessary that every time if a number is divisible by 4, it should be divisible by 8. So our first statement is false. Now the next statement is all numbers which are divisible by 8 also be divisible by 4. So this statement is true by the divisibility rules, because we just learned that if a number is divisible by a particular number, it is also be divisible by its factor. Now here we have number 8 and we know that one of the factors of 8 is 4, right? And also let's solve this statement by taking an example. If I take number 72, now 72 is divisible by 8. 8 9s is 72. Now let's check, is 72 is divisible by 4. So 4 1s are 4. 7 minus 4 is 3, 32. So that means 72 is divisible by 4. So hence this statement is true. Now the next one. If a number is exactly divides two numbers separately, it must exactly divides their sum. Now we are going to solve this statement by two parts. First we solve the statement up to here and then the next statement. So if a number is exactly divides two numbers separately. Now what you mean by exactly divides? When we divide a number by any other particular number, so we get remainder 0. Just like here we divide 72 by 8, so we get remainder 0. So we can say that 72 is exactly divisible by 8. Same here, 72 is exactly divisible by 4. So for that, let's take two numbers like 14 and 6. Now both numbers are even. So by divisibility of 2, I can say that both numbers are divisible by 2. So up to here, our statement is clear. We took two number and by number 2, both numbers are exactly divisible. It must be exactly divides their sum. Their sum, that means which two number we took, their sum is also divisible by a number. So 14 and 6. So 14 plus 6, that is 20. Again 20 is an even number, so it is divisible by 2. Now let's take another example. If I'll take 12 and 6. So 12 and 6 are divisible by 3. Okay, we know that 4 3s are 12 and 3 2s are 6. So both are divisible by 3. Now their sum is 18. 18 is also divisible by 3. So that means if a number exactly divides two numbers separately, it must exactly divides their sum. So this statement is true. Now the next one. The last one, if a number exactly divides the sum of two numbers, it must exactly divides two numbers separately. Now, if you read this statement carefully, it's just little bit converse of the above one. If a number exactly divides the sum of two numbers, so suppose I'll take number 36. Now 36 is the sum of any two numbers and 36 is divisible by 2. But if 36 is a sum of number 31 and 5. So is that 31 and 5 are divisible by 2? No. सम ऑफ टू नंबर्स तो हम किसी भी तरीके से एक्सप्रेस कर सकते हैं, ओके, बट दैट डजंट मीन कि वो 2 से डिविजिबल होना ही चाहिए. अगर मैं 36 को ऐसे एक्सप्लेन करती हूँ 31 + 5, सो ना 2 से 31 डिविजिबल है ना 5. सो दैट मीन्स इन एवरी केस दिस स्टेटमेंट इज नॉट ट्रू. सो this statement is false. So here question number 1 of exercise 3.5 is complete.